the mayor of a small city has suggested that the state locate a new prison there, arguing that the construction project and resulting jobs would be good for the local economy. A total of 183 residents show up for a public hearing on the proposal, and a show of hands finds only 31 in favor of the prison project. What can the city council conclude about public support for the mayor's initiative? So we need to construct a confidence interval to determine what the actual population proportion would be. We have information about a sample, but a sample is not always the most accurate representation of the entire population. When we construct a confidence interval, it gives us a much better representation of our population. So it told us that we had a total of 183 residents show up for the public hearing, and 31 of them were in favor. Our point estimate in this case, our sample probability, or p-hat, is going to be 31 out of 183. Now, in order to create a confidence interval, we first need to make sure that it has fulfilled all of the different requirements. So our first requirement is that it is a random sample, and we are going to assume that this is random for now. If we decided that we didn't want to assume it was random, at the end, when we are drawing our conclusion, we would just have to put a disclaimer that it wasn't a random sample. So we still have the ability to proceed. The second thing is that it has to fulfill bins. It has to be a binomial distribution. Is it binary? It is, because people voted either in favor or not in favor. The trials needed to be independent of each other, and they are, because each individual is their own person and they are making their own decision. And there has to be a fixed number of trials. We have a fixed number of people that were there in attendance. It was 183. And S, the probability of success has to remain the same. For any person, the probability of success is 50%. There's a 50% chance that they're going to support the initiative, or a 50% chance they're not going to support it. And then the third thing is that we need to have more than 5 successes and more than 5 failures. And we do have that. There are 31 successes and there are 152 failures. So now that we know that we can proceed, we go into step 2. Step 2 is determining our critical value. This problem did not give us a confidence level. Since it did not give us a confidence level, the default is to use 95% confidence. Since it's 95% confidence level, our critical value is going to be 1.96. And we looked at how to find that, but for 90, 95, or 99%, you can just use the the critical value that I gave to you in your notes. Step 3, now we are going to have to find our margin of error. And since we are dealing with proportions, our margin of error is our critical value times the square root of p hat times q hat divided by n. Remember that q is equivalent to 1 minus p, so therefore q hat is going to be 1 minus p hat. Substitute in our values. We get 1.96 times the square root of 31 out of 183 times 1 minus 31 out of 183, all divided by 183. And to make that a little clearer, it's all underneath the square root. I use my calculator, and I find out that my E is 0.054347799. So now that I have my margin of error, I have the ability to then go ahead and to create my interval to estimate my population parameter. My interval is going to be p hat minus E, our point estimate minus our margin of error, and p hat plus E, or our point estimate plus our margin of error. I have 31 out of 183 minus 0.054347799, and p hat plus 0.054347799. So I go ahead, use my calculator, subtract my margin of error from my sample proportion, and I end up with 0.115, which is less than P, and that is less than 0.224. So that is my confidence interval. Since it was a 95% confidence level, we can now draw our conclusion. And in our conclusion, we will say that we are 95% confident that the interval from 0.115 to 0.224 actually does contain the true population proportion. This is a very small probability or proportion of people. So somewhere between about 11% and 22% favor this construction project happening. So therefore, the city council can conclude that the public is not very supportive of the mayor's initiative. Roughly not even a quarter of the people, or not even 25% of people, are supportive of this initiative. Problem number 7. The Paralyzed Veterans of America is a philanthropic organization that relies on contributions. They send free mailing labels and greeting cards to potential donors on their list and ask for voluntary contributions. To test a new campaign, they recently sent letters to a random sample of 100,000 potential donors and received 4,781 donations. For part A, it says give a 95% confidence interval for the true proportion of those from their entire mailing list who may donate. Our first step is to see if the requirements are fulfilled. So is it random? It said that they sent the letters to a random sample, so therefore our random part has been met. Is it a binomial probability distribution? Does it fulfill bins? Is it binary? It is, because the individuals will either donate or they will not donate. The trials are independent of each other. It's a fixed number. They sent it out to 100,000 individuals, and the probability of success is 1/2. For part 3, we need to have more than 5 successes and 5 failures. Which we do, in fact, have more than 5. There were 4,781 successes and a whole lot of failures. So we are ready to move on to step 2. Step 2 is identifying our critical value. That's our z star, or z sub alpha divided by 2. Since it's a 95% confidence interval, from our notes, we know that that critical value is 1.96. Now we are ready to find our margin of error. Our margin of error is going to be our critical value times the square root of p hat. So p hat is our probability of success. There were 4,781 out of 100,000 that donated. So that is our success. And then our failure, or our q hat, is 1 minus that fraction. And we have to divide that by 100,000. We're going to use our calculator. So now we need to calculate this. So 4,781 divided by 100,000 times 1 minus that value divided by 100,000. Then we take the square root of that, and we're going to multiply it by 1.96. And we end up with 0.00132292. So our E is 0.00132292. That is our margin of error. And so once we have our margin of error, we can create our interval. Our interval will be our p hat, 4,781 over 100,000. Minus our E, and our point estimate plus E. I'm going to take 4,781 divided by 100,000 and subtract the value we found before, and I'm going to get 0.0465 is less than P, which is less than that plus that 0.0491. There is our confidence interval. And now we just have to make our conclusion. So step 5, we can say we are 95% confident that the interval from 0.0465 to 0.0491 actually does contain the true population proportion. And now for part B, it says a staff member thinks that the true rate is 5%. Given the confidence interval you found, do you find that that percentage is plausible? Well, since our confidence interval is from 0.04 or from about 4.6% to about 4.9%, it does not contain 5%. Therefore, it is not a plausible percentage of those who donate. So, since the interval does not contain 5%, it is not a plausible percentage.